I mean, if we just are given any three positive numbers, is it the case that we can make a triangle where the lengths of the sides of the triangle are, in fact, those three positive numbers? We know the answer is no by the triangle inequality. We know that a particular inequality has to hold. So let's tell whether a triangle can have the sides with the given lengths. So here we go. 6, 10, 14. Well, the way to check this is to look at all the possible sums of 2 and make sure they exceed the third. 6 plus 10 equals 16, and that exceeds the third. 6 plus 14 equals 20, and that exceeds the third, which is 10. And finally, 10 plus 14 is 24, and that exceeds the third, 6. And so the triangle inequality holds, which means we can actually produce a triangle, one side of length 6, one side of length 10, and one side of length 14. Neat. So the triangle inequality is sort of a handy little tool to have around, and in fact it's used all the time in advanced math. When I do my own mathematics, where I'm discovering new math, I'm using the triangle inequality all the time. Isn't this cool? We're sort of sharing a triangle inequality together. I like it. I like it. All right, let's try this one. Can we have a triangle, side lengths 5, 9, 14? Well, let's see if the triangle inequality holds for all possible sums of 2. So 5 plus 9 equals 14. Is that greater than the third side, 14? Well, the answer is no. It actually equals 14. So this is not a triangle. If you try to make it a triangle, here's what would happen. I'll try to draw it for you right now live. What you've got here is you've got a side of length 14, and then you've got a side of length 5 and a side of length 9. So if I put the 5 side here and the 9 side here, to get them to touch, they'd have to sort of collapse right onto this line. You see, here's the 5, and here's the 9. You see how they all have to line up perfectly? Because there's no room to have them bow out to make the triangle tip-top, rooftop thing. And that's not a triangle, that's a line segment. So in fact, the answer is no, we can't make a triangle out of this because the triangle inequality is not satisfied. I'm sorry, if you like those three numbers, we can use them for other things, but not for the lengths of the triangle. How about this? A minus 1, a squared minus 2, and 3a, where a is the number 4. That's a cryptic way of saying three numbers. Let's see if we can figure them out. If a is 4, a minus 1 is 3. If a is 4, a squared is 16, minus 2 is 14. And if a is 4, 3a is 12. And the question is, will this form a triangle? Well, we ask if the triangle inequality holds for all pairs of sides. 3 plus 14 is 17, which exceeds the third side, 12. 3 plus 12 equals 15, which just barely exceeds 14, but it exceeds 14. All we care about is if it exceeds 14. And 14 plus 12, well, that's 26, which is certainly bigger than 3. And so, yes, you can have a triangle that has these lengths. Very, very, very cool. The triangle inequality, something not to be messed with.